Our universe is incomprehensibly vast, with billions of galaxies, each containing billions of stars. The uncharted territories offer us a chance to study the phenomena that challenge our current understanding of physics and astrophysics. Asteroids, once overlooked, are now the focus of new era in exploration. These celestial rocks scattered throughout our solar system harbor a wealth of opportunities waiting to be harnessed. Asteroids are like time capsules from the early solar system. They contain valuable metals, minerals, and even water, which are essential for future space exploration and sustaining life beyond Earth. The idea of mining asteroids may sound like science fiction, but it's becoming a tangible reality. Water and oxygen are critical components for the human space exploration, and finding sustainable methods to extract and process these resources in the space is essential. This brings us to our mission of ISC 2023 of extraction and collection of usable minerals from space objects. For space mining to become a reality, many questions still remain to be answered. From a scientific point of view, detailed data from astronomical bodies, from asteroids to moons to inner planets to exoplanets, each posing different challenges will be required. Due to different environment, different circumstances, there has to be different mining methods. For example, the mining method that you can use on extracting on the planet Mars cannot be used for extracting in a airless atmosphere or in a vacuum objects like moon or asteroids.
Space mining refers to exploration, exploitation, and utilization of resources beyond the limit of Earth. It can be done on Moon or other planets or natural satellites or asteroid. Mining on asteroid refers to asteroid mining. Now it's come to the question why the need for asteroid mining arose. It's because as the human population is growing on Earth, exponentially their needs are also growing for various different kind of metals and other minerals. The deposition of metals and other minerals in the earth are depleting day by day as per the requirements of humans. It came as a question to us that what would be if all these minerals got extinct. The answer to this we got is we can use the minerals or the rare minerals that found outside the earth on other planets or asteroids.
Kalam Exosat Miner mission is a space mission designed to explore a near-Earth asteroid 511 Davida. Davida is one of the largest asteroids in the asteroid belt between Mars and Jupiter. It is a 326 kilometers wide and is classified as C-type asteroid, indicating a composition rich in carbonaceous material. Launching this mission on Falcon 9, which is a two-stage rocket. The first stage is reusable stage, which separates after about 2 minutes and 45 seconds of the launch. The second stage that is responsible for delivering the payload into its intended orbit. After about 8 minutes from the liftoff, the payload is deployed in the low Earth orbit. The satellite will do required maneuvers, and after spending few years in the orbit around the Sun, it will finally reach to Mars, whereafter with the help of gravity assist of Mars, it will finally reach to its destination, that is the asteroid Davida 511.
It will take about 2 years in orbit around Sun to reach the asteroid belt where Davida 511 is located. After 2 years in orbit, Pragyaan begins with its approach phase. Its thermal and near-infrared camera captures the image of Davida 511. After a month, Pragyaan reveals its shape, rotation, and color for the first time. After chasing its target for over 2 years, Pragyaan arrives at asteroid Davida 511. Pragyaan fires its thrusters to match the velocity and rotation of asteroid and get captured by its gravity. Then it will do a general mapping of its topography to find best suited landing site by using LiDAR. It uses Star Tracker to align its position, thus making it move in the right path. Then Pragyaan will begin its reconnaissance phase. It will break the orbit and land at the best location for mining at 30 kilometers from surface. KHM will match Davida's speed and rotation necessary for safely landing on the asteroid.
While KHM descends to the surface, it deploys its movable robotic arms and its scraper and sweeping brush, which is the new innovation done by our team Pragyaan 1 for this mission challenge. When the KHM lands perfectly, it starts with its first phase of converting solar radiation into laser by using solar reflector to concentrate on a focusing lens. Then this beam is passed through solar pumper, which is made up of cerium neodymium doped lithium aluminum granite rod, which convert into laser. This laser start breaking the surface. After some times, when the surface breaks, the KHM moves slowly to the break portion and, and enclose the surface with brush container. Inside this container, the brush scraping part rotates and scrap the loose surface, then passing N2 gas from sides to collect the break sample particles while allowing the gas again into the fuel tank after filtration. This process will go on till it collects enough amount of samples. It also uses many other instruments such as gamma ray and 2 neutron spectrometer to determine elemental makeup of asteroid surface. Second, near and thermal infrared imager for remote sensing and to measure lander surface temperature. Third is the ONC for capturing image of the surface. Fourth, LIDAR for determining its altitude, topography, shape, color from far distances. And the last is X-ray spectrometer for elemental and chemical analysis. When all the functions are performed, it will fire its thrusters. The thrusters we have used are Hall effect thrusters, which uses electric propulsion system.
Using thrusters, the spacecraft departs from Davida and returns back to Earth. 3 hours prior to the arrival to the Earth, the KHM will release the sample capsule and the capsule will return back to Earth collecting the precious cargo collected from the asteroid. The total time taken by the mission from liftoff to splashdown will be about 6 years.